Okay, so today I am going to do part 4 of the hash table implementation in Python. And I think it's almost getting to the place where I want to leave it there, but let's see. I kind of want to also start soon to do it in Golang. So this is what I basically still have to do. So currently going to do V3. So what has been implemented? So double hashing for collision handling, then resizing the hash table when the load capacity reaches 0.75. So I think I can play around with this value. I added some initial unit tests and also initial like stress test. So then what I will basically improve upon now is I just will do some miscellaneous improvements. I also need to improve the deletion method. So I need to add another counter, which keeps tracks of all the occupied slots. And then this is needed because the load factor is now going to use this instead of the size counter, because this will include all like soft deleted elements and active elements as well, because those are like as I explained in the previous video, like we cannot, if we want to delete an element, we cannot just set it to null, because if we need to search for an element that had to be like that was probed for insertion, and if it has to go through that deleted element, it will basically return, so the get function will basically return none, right? Even though the element we're searching for still exists. Yeah, and we should also resize. We should also resize down to a factor, right? So we need to update the resize method as well. Well, actually, no, we don't need to update the resize method for that, but we need to add the resize basically down logic there. But I'll actually also have to update the resize method actually, because we have to resize down. But anyway, we'll see that in the code. Also update the load factor calculation. So previously we had this alpha equals S over M, where S, or this is what it has to become, right? So we have the slot counter, which is actually, it's this one here. So the occupied slots. And M will be, of course, the total slots, the length of the hash table, instead of this one, where previously we had N was the size counter, which did not take into account the soft deleted elements. So the size counter only had like the active elements. Yeah, basically also add unit test for resizing down, and then profile the stress test to see like the time it takes for all the operations. Okay, so I have to now do this. So active slot counter, I'm just gonna do this really quick. So lookup. So now, okay, so it's gonna be 0, and then yeah, okay, yeah, size. Okay, so let me rename this. So rename. Okay. So that's one thing. Let me see what I'm forgetting here. Rename buckets to slots. Yeah, okay. Rename buckets to slots, sure. So yeah, these are not like buckets anymore, more slots actually. So slots. And I also want to make them private, but anyway, I will do that later. Okay. So have the resize. So the other thing I'm gonna do is where is the other variable? Occupied slot counter, right? So set this to 0, and then I'm gonna update this here, right? So load factor is updated, and then resize. So I want to say new size. Oops. Gonna do int. And it's gonna be the new length here. Okay. So yeah, I'm gonna put this also new slots here. New slots. Okay. And let's see, resize. Okay, I have this one here. So this is going to be self.length. We're gonna make it double times 2. And okay. And now we are also going to do this. So load factor, we need a, yeah, maybe we can decrease it, maybe like 60% will perhaps. I don't know. So this is going to be called resize up threshold. I'll rename this to resize up threshold. Then this is going to be called resize down. And 0.12. So let's search and delete. Okay, so I think, yeah, this has to be done after an item is deleted. So we have to go here. And we are going to say load factor here. So compute load factor. Okay, so if it's smaller than or equal to, we will resize down by half. Yeah, times 0.5. Resize down by half. And then we will return true. And we will do the same here. All this one here. Here, perfect. So we have the new slots here. This length is equal to the new size. Then active slot counter will be set to 0. Right, and then here in insert, active slot counter will only have the active keys here. Okay, perfect. Okay, so that seems correct. Yeah, so basically, like, for example, if in the hash table there's a lot of elements that are like have been soft deleted, then we can like basically resize down, right? Because we are, yeah, we could have a lot of like wasted space. So then we can resize down, and we of course will omit those elements and only rehash the active, basically the elements that have not been soft deleted. So one thing I would like to do actually, this one could be just called is soft deleted as well to be consistent. Is soft deleted. Okay, perfect. And so here, so deleted. Okay, so let me see what else. Rename, very fine. Proof deletion method. There needs to be when an item is inserted into the occupied incremented. Yep. Okay, so we need to also insert. So we need to say the occupied slot counter. So self dot occupied slot counter. Whoops. So we also incremented this one, which is occupied. We increment it here. And this one, yes, but here we do not decrement it. So I'm just gonna put here. So this one is not decremented because we are keeping track of all the occupied slots. So when an element is self-deleted, like this will not be decremented, only the active slots. Because technically, I mean, there's still, it won't be like considered to be active. Okay, yeah, this one is done. Update resize method, the load factor calculation. Sure. Add resize profile test, So this is mostly, yeah, pretty much done. So now I'm just gonna run some tests. The tests again, so let's say pi test. And of course, there is some failures. I'll take care of that later on, but okay, but that's good. Some tests are failing. Okay, so I'm gonna make these private. Doesn't make sense to have them exposed to the client. And okay, and let's see if this was actually where the references to this. So new size, lookup. Okay, perfect. And let's see the tests. What are the tests? This lookup. Active slot counter. So maybe I can say, yeah, get size. So here I can have a method that says like get size or something like that. So def get size. Active slot counter. And I'm gonna update these guys here. So okay, so get size and rename single occurrences. Get size. Perfect. Okay. These are all the ones. Okay, perfect. Okay, now let's fix this. So let's see, then deletion when table is not empty and probing does not need to be done. Float cannot be interpreted as integer. Okay, probably in the resize. Well, let me see. Let's comment this out. Let's comment this out as well. Now I'm gonna run them again. Pi test. Nope. Okay. Okay, so yeah, it's probably this thing here. So let me, I'm wondering if, yeah, this is probably, of course, a float. So let me see. I think we, let's see. But this is also repeating itself too much. So we can say like, maybe like new size. You can say self.length. Okay, new size. So let's see. It will be an int, of course. And of course, this, like, let me just check. This should be a float, obviously, times 0.5. Yeah, of course. So yeah, here's probably the error. And let me uncomment this, guys. Okay. So let's run the test again. Okay, so this insertion where resizing is needed. So of course there is some, maybe I have to update the unit tests. So there's two that are failing. So this one. This one here, that I'm gonna comment out for now. I'm gonna say pass. And or wait, let me just comment actually down the end-to-end one and start debugging it. Start debugging this one, which is shorter. Okay, so we have this. So where is this failing? Resizing. So in resizing. So let's see. So if I run this, it's gonna say clear. Okay, perfect. So it's failing in resizing. Okay. One method I want to kind of also get is for, so get slots. So I'm gonna say def get slots. Okay. So I'm wondering here, I'm gonna say like print lookup.get get slots. Let's see what it looks like. And what is it? Print -s, I think. So we have 11, Q4, Q5. Okay. I'm calling this. Okay. So length. We have to see also if it resets here because we changed the factor. We changed the factor. So let's did I make this private? No, I didn't. So yeah. So probably resize was done somewhere here. So that's, let me print it out because since I changed the resize factor, print resize. Okay. Yeah, so it was resized before. Okay, fine. So let's, yeah, because the factor is the size factor was, so basically, if I change the, it would be good to like just have an isolated method, because then it's more controlled when we actually need to resize. Because like if I change the factor, then it's easier to like just track down the unit test. So I'm just gonna rename this like test insertion. So just test insertion. And then I'm gonna create another one. So dev test resize up. And then I'm also going to have a test resize down as well. So let me also take some of these, reuse some of these. So and print this one. So let me just print this to see. So now, where does it resize? Oh my God. Jesus. Okay, let me see something here. Help. Test paths. Directories for sure for attachment of file, the directory given to the command line. Let me see if I can, I just forgot the syntax actually. What was it? And test. So test, lookup, and I think it was maybe like this, I think. Test lookup. Nope. Forgot the syntax actually. Let me see. So test specific function. Let me see. Run tests in a directory, run tests in a module. Test, run to run a test within a module. So maybe like this test font. Okay, yeah, sure. And then we have this one. Let me see if no test lookup. Fine. Let me see if I have two. If directory. Yeah, there it is. Okay, perfect. There it is. Nice. Okay, cool. So this didn't need to resize. So let me go like here, like this. Run this again. And I'm gonna also update actually my README here. So to run fig fast. Okay. And now let's get this guy here. This one will need to resize here. Dash S. So yeah, look up that resize and do it again. Okay. So this one resized. So it was 5. So now we have to say assert dot length. Oops. Lookup dot length equals 10. Yep, perfect. So one thing I also want to do is run this big test, unit tests. So to run all unit tests, okay. So, and then so if and include prints dot events. So to include sprint statements, we use the S flag. Perfect. Okay, nice. We have this. Okay, so this is looking good. So now we have to test resize down. So let's maybe copy this, guys. And then I want to delete. So lookup dot delete. And then I'm gonna delete key 5. Minute, because I also need to resize up. Where's resize down? Come on. Delete. Oh, okay. It has to be resize down. Resize down and resize down. So now let's yeah, let's just print this here. Okay, it's misspelled, but I don't care because it's temporary. I'm kind of tempted to have like another function. This is like repeating itself here. Okay, but let's leave that for later. But yeah, this would be good. Like this, you know, this is being sprinkled all over the place. So would be good to remove encapsulate somewhere so it could be more clean. Okay, but let's worry about that a little later. So test resize down. Okay, so delete, and then of course, test deletion. Okay, assert R equals true. Test resize up, test resize down. So will be R assert R equals true. And then now I am going to resize down. It's this one instead. Okay. So now I'm gonna delete 4. Okay, and now I'm gonna delete here 10. Whoops. Let me just print. So lookup dot get slots. Okay. So now let me just compute the load factor as well, if you want to see. So it's gonna probably error out because this is private. Let me just see. It's gonna error out now. Yeah. So let me or actually get load factor. Why not? So there. So get load factor, and I'm gonna return compute load factor. That's what I want to see here. So it's 0.6. So 0.6, seriously down. I also have occupied slot counter. I think I need to keep resizing actually. So let me actually. Okay, like I know this works. I'm just gonna delete this for simplicity's sake, because we're not testing that. So insert. Okay, so 11, 20, let's put 25. Is it looking? Okay. A bunch of slots. Testing those. So now resize down threshold, resize. Um, Well, actually, I'm gonna say, okay, keeps track of all occupied slots, both active and soft, deleted. Only keeps track of active slots. So deleted will not be counted. Mm-hmm. Okay. I'm just trying to think, how can I make this into smaller? Because if I have a lot of these guys, deleted and okay. I think the length will probably need to just be larger here. So let me do something. Say it like this. And comment this out. Yeah, 0.04. So let me just 0.2. Yeah, there's no want. So let me just kind of trial and error here. 25. 25. So 0.2. 0.025. Okay. And what is 0.12? So, okay, so this will resize here. So this will resize here. So then if we delete, we should have the resizing thing. So delete, yeah, delete 5. Didn't resize actually. Why? 0.12 is smaller. So let me see. Okay, fine. Resize down. And now let's print this thing. So let's print before and after. So just want to see how it looks. So yeah, we have a bunch of non-slots. So why do I have this one here? Which is weird. So wait a minute. Let me see. Print lookup.length. Run this again. So 22. So up here. So this is, yeah, I mean, it is resizing down. And I think I'm pretty sure 100% of it's working or not. But let me see here before print length. So Also comment these things out. Clear. So I have 45, of course, and then resize down to 22. Wondering if, yeah, well, yeah, I mean, I think that factor will be fine by half. Okay, fine. Well, this seems to be working. So I'm gonna load factor 0.4. I am going to assert. I'm gonna say lookup.length equals 45 divided by 2. So let's run this as well. Okay, fine. So now I'm gonna remove the print statements here. This one here. Okay, so I am going to, let's see what else. What else is there to do? So let me run all the tests as well, like pi test. Oh, one thing I need to do this end-to-end thing. It's probably gonna fail as well because I'm like testing the resize in the wrong place. But it's, yeah, it's fine. I mean, I'm going to maybe remove this one here. This assert here. Okay. Lookup.length equals 10. This one here as well. But it's not really needed. Okay. Perfect. So here it is. So everything is passing. Okay, cool. So let's see what else I had. Profile resize. This thing is done. Okay. Okay. Yeah. So all of this is complete. Resize. Okay. So now, yeah, let's profile the stress test and then run it as well. And then all the miscellaneous stuff. Yeah, everything is done as well. So the miscellaneous stuff is done. So profile the stress test. So we have this like a simple stress test that I did the last time. So one thing that I want to do is kind of like just profile really quick how long do each operation takes, like insert, search, and delete. So for that, I'm just going to create a decorator. So we're gonna say like, yeah, def timer, and we're gonna have the famous args and q args. The arguments and key arguments. And then I'm gonna have the start time equals time it. So time it. So I think it's import the time it thing, native Python module. So time it, default timer, and then I'm gonna say, so let's see, value equals conc, and then we're gonna have the key args thing here. Okay. Oops. And I also need the passing the function. Let's see. The function. And then we're gonna have end time equals timer dot default timer. And then I'm gonna say run time equals end time minus start time. And then I want this in milliseconds. So I'm gonna multiply it by 1000. And then after that, I'm gonna print this thing. So it's gonna say Flonk, oops. Flonk name. I believe that's how it is. So Flonk name executed in, we can say milliseconds. Oops. And then here we say milliseconds. And then we say we return the value. And actually, okay. There is one mistake actually did. So I have this here. This is actually not here. This is here, so we have to say def. Yeah, why not like time? This inner function. So this is like a classic way to define the decorator here. So that's what I'm creating. Okay, oops, perfect. So we have this thing here. We return here. And then I have my args and qargs. And then after that, I return the function itself. Perfect. So this will basically take the function, right? We are going to decorate. We're going to run it. We're going to time it, right? And then we basically return that same function here. And then this thing is returned, right? This inner function is returned. So then like that, we can call it here and say timer. I think so. I think so. So let me just run this really quick. So Python main dot py. Let's see. Yeah. So okay, yeah, of course, like this is all executed here. Wait a minute. So I have to do something else. Sorry. I have to make some of these methods. So we're gonna say insert. Of course, that will benchmark all the thing. And now I'm gonna say we're gonna say key. It's gonna be any. And then I'm gonna say value as well. Value as well is gonna be any. And then I'm gonna say lookup here as well. Dot insert key and value. Okay. And then I'm gonna do the same here. So instead of insert, it's gonna be delete, and then delete by key. And I'm gonna say search. I'm typing import any, perfect. And then of course this is going to add here. Oops. Like this, and then we replace. There's gonna be insert, delete, and then search. And that thing that should start to execute this thing. So let's run it now. Missing one. Okay, line 21. I don't know why this is complaining, in fact. Why is this complaining? Ah, shit, because lookup. Forgot to put lookup here. Lookup. Okay, let's run it again. There it is. It's running all of this stuff, and yeah, I mean, pretty much constant time, right? Like practically 0 milliseconds. Of course, like CPU does go up a lot, right? So it's quite heavy CPU intensive. And then when the thing stops executing, of course, the CPU usage is gonna drop a lot. Okay. So let's see. This is interesting. Active slot counter. Dot get size, get slots, or get size. Okay, so we have this. Okay, boom. Okay, cool. And then, okay, fine. So I'm gonna, yeah, bump this up. So right now it's 200,000. So let's say like 800,000 actions. And yeah, I mean, it will still always run basically on this amount of elements, on this runtime, basically. So it's 0.00 milliseconds each operation. So that's why like hash tables usually have, right? Like that's why people, it's constant time lookup, insertion, and deletion, even though probing happens. But the possibilities of probing happening are not that high as well. So that's why like, average case is always constant time operation for search, deletion, and insertion. So I think this is yeah, I think this is a good time to culminate this. Of course, like one interesting thing, although I believe I haven't done a lot of like in-depth research on how we can handle concurrency here, but I believe, again, like I have to double check. I believe that Python has a global interpreter lock, and if I think that guarantees also like some type of thread safety, because only one thread in Python can execute at a time. So Python is not like multi-threaded per se because of the global interpreter lock. But yeah, I mean, I'll have to test. But definitely, like if this is implemented in Go, like we can basically handle concurrency, right? So we can basically have like some thread pool, that can basically manage the threads of execution. But maybe one interesting thing that would be nice to try, like if this actually gets deployed, like somewhere, like just to test, like if I build like some type of CLI client, and then this thing is like has like an API that the CLI talks to, and then that API directly will interact with this thing, with this hash table. Like you can, yeah, basically create like different hash tables for different use cases, and you can like store data and then do all these operations. So that's like one part of the thing. Like if it's gonna be right, well, this is actually already done. So improve resize. I mean, that's I think standard resize logic. So I think I'm gonna cross it out. I mean, I'm gonna delete it. So So yeah, this thing, concurrency, like we're gonna turn this thing into a cache. Yeah, so maybe we can say like API, CLI, client. Although this could be interesting more to do it in the maybe, yeah, in the Go version. This could maybe, yeah, we could maybe try to do this, convert it in the Python version. So I think, yeah, I think this is it. I mean, yeah, I mean, I could later on like just document, add some like comments here, like F-string documentation. But yeah, I think this is basically it. I'm also tempted to maybe print here. Doesn't take so long. Say maybe get slots. And let's see what other. No, actually not slots because that's gonna print. So maybe like this. I mean, I could even have like maybe some interesting metrics like total, maybe inserts. Let's see. Okay, let's do this like total inserts, and then I can have total search, total searches, deletions, and then I can have this, right? Searches. And then let me okay, yeah. So now I can say, for example, print, and I can say so total inserts. And total searches. Oops. So in searches, inserts, and then we have here deletions. And let's see, I think, let me see, I don't want to return. See if I can actually do this. Let me see. Let me see. And then I think this should return the runtime because that's what I want. So let me see if this is runtime. Runtime here, here. So average run insert runtime. And then I'm gonna say the same here. So search. And then Okay, so now we will say average insert. Runtime. So we're gonna say searches executed at an average runtime of divided by total searches. So we have total searches here. And then we're gonna copy this thing. So total inserts, insertions, executed, and then average insertion. So inserts. So we say here, and then total inserts. And I'm gonna say deletion. Deletions executed at a right runtime of, and then we're gonna say average deletion, total deletions. I think this would be maybe more interesting. So let's see. Boom. Okay, boom, boom. Okay, cool. Yeah. So yeah, like for 45,000 searches, 40 insertions, and 14,000 deletions executed at an average time of this, right? And then we can say like milliseconds, of course. And yeah, I mean, what can I mean, let's see, rounds. I mean, so I kind of want to do this as well. Digits. So what it says, return the value or non. Okay, digits. Well, why not? Let's put like fine, four digits. So I'm gonna do the same here. So round this one here and then 4. Oh my god, it's really annoying. Okay. So basically 100,000. Okay, so 500,000. So 500, let's say, or 1,000. Let's put here. It doesn't take as long. So yeah, like basically almost at 0 milliseconds, right? 0, 0. So I just left these 4 decimal places after, right? The 0. Yeah, they practically 0 here. Okay, so I think this is it. So I think yeah, for now, I think it's enough. So I'm gonna, yeah, basically commit this. So okay, git commit, and I'm gonna say added resize down modified. Let's see what's it called. So modified method. So it uses the new then of the size variable. So the keeps track of all occupied slots, including soft, deleted, and active. What's the other thing that was done? So the size variable was renamed to active slot counter, which can copy this of active slots, right? So that's the other thing. And then the other thing that was done is that, well, yeah, insert search. Yeah, so modified the resize method. So it can takes a new size as a parameter. And then the other thing that's done modified. So it resizes if the load factor is below the resize down threshold, right? And then this was also introduced. And set 0.12, right? To determine when the resize is needed. And then we're gonna say so 5 updated unit tests and added specific tests to well, let's call it methods to test the resizing logic up and down. And the last thing that was added, so profile, yeah. So added decorator to profile the stress test runtime for each individual operator in the stress test in the stress tests in the stress what would it be? Stress test, profile test, profile stress method. In the profile stress test method. Okay. So quite a lot of stuff, and then we can push. Okay, so I think yeah, this is would be all for this video. So I think I am reaching basically a stopping point, or close to stopping point with this half stable implementation in Python. So I'll see what else needs to be done. So maybe I will decide. Maybe if I start to implement this in Go and do all the like the CLI client in Go as well. So yeah, let's see what I decide. So then if you tuned in and listen through all this, well, yeah, cool. And I guess I will see people that jump into these videos in the next one.